Hey everyone, in this video, we're going to be talking about how to calculate the average rate of change of a function. So this is an AP Calc topic that kind of gets forgotten, and students kind of like when the AP test comes around, they forget what this term means and then they kind of trip up on those problems. But I just want to say right now, it is very straightforward. And if you know how to calculate the slope of a straight line, you already know how to calculate average rate of change. So it's very straightforward, shouldn't require a lot of extra work. Just make sure you remember what the phrase means so you can do those problems. So to explain it, we're going to look at this function right here. And this function has feet on the y-axis and then minutes on the x-axis. So it is a displacement function that's telling you how far you've traveled in feet after X amount of minutes have gone by. And so we're going to look at the spot specifically between 2 minutes and 10 minutes. So maybe this is the time after you've left your house and you're on a walk. And so if we look at the time between 2 minutes and 10 minutes, we can use this graph to figure out how fast we were going, right? Because the derivative of a displacement function is velocity. So that tells us how fast we're traveling. So if I look at this function, if I look at around the 2-minute mark, we can see that I have a negative slope there, right? So that means my velocity is negative. So maybe I'm traveling back toward my house. But then as time goes on, the slope changes a little bit. So right here, we can see that the slope is kind of flatter. So maybe you're not going very fast. Maybe you're come to a pause. And then as we get closer to 10 minutes up here, the slope changes and is positive again. So that means we're traveling faster. So we know that at each moment, our speed or our velocity is changing, right? So it doesn't really stay the same. However, what if I wanted to know, between 2 minutes and 10 minutes, how fast am I going on average? Like if I were to average out all of my speeds, what would be the average velocity that I'm traveling? So that's the exact idea that this average rate of change gets at, is on an interval, on average, how fast do you think you were going? So to calculate that, what we would do is we would draw a straight line that goes between these two red points. So that line's going to look something like that. And so to calculate the average rate of change, all we need to do is calculate the slope of that purple line. If we can calculate the slope of that purple line, then that'll tell us how fast we were going on average. So to do that, we can use this formula right here. And this is our average rate of change formula. So hopefully this looks really familiar to you, right? If you look at the top, you have f of b and f of a. Those are both y values of the function, right? And then on the bottom, you have b and a. Those are both x values of the function. So we have two y values on the top that are being subtracted from each other, and then two x values on the bottom that are being subtracted from each other. So what we're doing is we're calculating what is the change in y values and what is the change in x values. And hopefully that looks really familiar to you as rise over run. So this average rate of change formula, all it is just the slope of a straight line. That's the exact same thing. It's just written using a different format. But it means the exact same thing. So if we were to calculate average rate of change of this function f of x between 2 minutes and 10 minutes, all we need to do is subtract the y values and then divide that by the x values subtracted. So f of b, that's the y value of the second point. So that is the y value of this point, which is 14. And then now we need to subtract the y value of the other point, which is 6. And then we need the x value on the bottom. So the second x value is 10. So that goes right here. And then the other x value is 2. So that's all we have to do. And then we just calculate that. So 14 minus 6 is 8. And then 10 minus 2 is also 8. And so that gives us 1. So that means the average rate of change of this function between 2 minutes and 10 minutes is 1. So if we were to use the units of this problem, that means on average, you travel 1 foot per minute when you're out on this walk. So hopefully you can see it's all it is just calculating the slope of a straight line. You just need to know where to get your f of b, f of a, b, and a from, and then you're good. So, and then one vocab word that I want to mention that might come up in AP Calc is the word secant line. So a secant line is this purple line right here. And all it is a line that touches the function in two spots. So you can see this purple secant line, it goes through this point and it goes through this point. It touches the function in two spots. So it's a secant line. So just keep that word's good to memorize because it might come up in AP Calc. Okay, so now we're going to do this example. We have the function f of x, which is equal to x squared, and we want to find the average rate of change between x equals 2 and x equals 4. So what I'm going to start with, and I recommend that you do this whenever you're doing these problems, is just start by writing the average rate of change formula. So that is f of b minus f of a over b minus a. Okay, and so now we just need to know what f of b, f of a, b, and a are. So b and a are easy, right? So b is the second x value, which is 4. A is the first x value, which is 2. And now we just need to know what f of b and f of a are. Well, f of b is just what you get when you plug 4 into this function x squared. And if you plug 4 in, you have 4 squared, which is 16. And then f of a is what you get when you plug 2 into this function. If you plug 2 in, you have 2 squared, which is 4. So now all we have to do is just plug those numbers into this formula. So we have f of b, which is 16, minus f of a, which is 4, over b, which is 4, minus a, which is 2. And then we just simplify. So 16 minus 4 is 12. 4 minus 2 is 2. And then 12 divided by 2 is 6. So that would be our answer. The average rate of change of this function f of x between 2 and 4 is 6. And in this case, there aren't any units because I wasn't given any units for this problem. There was no feet and minutes involved. So if they don't give you any units, then your answer would just be 6 is the average rate of change. And so one thing I just want to mention, sometimes when you're doing these problems, they might word it like this. They might say, find the average rate of change of some function on the interval 2, 6, on the closed interval 2, 6. And so don't be tripped up by this. All this means, this is the exact same thing as saying, find the average rate of change of some function between x equals 2 and x equals 6. So the two numbers in this interval are just telling you where you're starting and where you're ending for this average rate of change calculation. So these two things in purple here mean the exact same thing. It's just two different ways of phrasing it. So don't let that trip you up when you're doing these problems. So I hope that was helpful for you. Again, it's a straightforward, easy concept, but just make sure you don't forget it on the AP test. And there's a link in the description of this video with a worksheet with some practice problems for average rate of change. So check that out. And if you can do that worksheet, no problem, then you'll be absolutely set for the AP test. And make sure to like and subscribe. Thanks.